Okay, this is the AP Pre-Calculus 2025 FRQ questions. I'm going to go over number 1. Number 1 says the function f is decreasing and is defined for all real numbers. The table gives values for f of x at selected values of x. The function g is given by g of x is equal to negative 0.167x cubed plus x squared minus 1.834. Part A, part 1 says the function of h is defined by h of x is equal to the composition of g and f. Find the value of h of 1 as the decimal approximation or indicate that it is not defined. Show the work that leads up to your answer. So for A, part 1, we need to find h of 1, where h of x is equal to g of f of x, so that's just f of 1. If we go up to our table, f of 1 is 1.75, so I need to find g of 1.75. So for my equation for g, I have g of 1.75 is equal to negative 0.167 1.75 cubed plus 1.75 squared minus 1.834. And then plugging that into my calculator, I get h of 1 is equal to 0.3335. Okay. Part 2 says find the value of the inverse of f at 3.5 or indicate that it is not defined. So if you look at the table, we have the function of f, and I know that for the inverse of f, that my x and y values are going to change. So I can just find 3.5 for f of x, and then the corresponding x value will be my answer. So that's why the inverse of f of 3.5 is equal to 0. Okay. B, part 1. Says find all the values of x as decimal approximations for which g of x is equal to 0. So if I graph the function g of x and set this equal to 0, what I'm trying to find are the x-intercepts. So looking at the graph, I get x is equal to negative 1.23, x is equal to 1.58, and x is equal to 5.64. Okay. B, part 2 says determine the end behavior of g as x increases without bound. Express your answer using mathematical notation of a limit. So what it wants us to find is the limit as x approaches infinity of g of x. So that's the same as limit as x approaches infinity of negative 0.167x cubed plus x squared minus 1.834. And if we plug in all those values that are going to lead up to infinity, we're going to find that this limit is equal to negative infinity. Okay, part C, part 1, says based on the table, which of the following functions best models the function f? Linear, quadratic, exponential, or log? So what I would do is I would look at my points on my graph up here, and I would try to either plot them on my calculator using lists and spreadsheets, or just do a rough sketch of what this function would look like. So I have negative 2, 14, negative 1, 7, 0, 3.5, 1, 1.75, and then 2, 0.875. So I'm noticing that this function is approaching 0, but never really kind of touches that 0 there. And to me, this looks exponential. So I'm going to choose exponential. And then lastly, for C, part 2, it says, give your reason for your answer in part C, part 1, based on the relationship between the change in the output values of f and the change of the input values of f. Refer to the values in the table for your reasoning. So another reason I would say that this is exponential is because as the input values increase by 1, the output values decrease by half. And I can see that here on the table. Each of these, we're adding 1. And then each of these here, they're decreasing by half. So 14 divided by 2 is 7. 7 divided by 2 is 3.5, and so on and so forth. They are decreasing by half values.